Hello friends, in the last session we have specifically seen about the cube and the hexagon. Here we'll go further. We will try to find the relation between the cube and a sphere. Now the sphere is there, we have a radius over here and we have the diameter. Now the diameter of the sphere which is there, that is equal to the length of the cube over here. So let's try to get more into the details of this part. Just to quickly recap, in the last session, we have seen how the hexagon is actually a cube in a 3D format. So we need to study the 3D objects. So this is from Master Commodity course. We have seen the hexagon, how this can be viewed as a 3D cube. This is both the hexagon and the cube together. Now, as we progress further, we need to find the relation between the circle and the square. I'll tell you why this is important for us. This is the Gann emblem. So the Gann emblem has a circle, it has a square as well as a triangle. This is the Gann emblem from W.D. Gann's Master Commodity course. Just probably highlighted few of the parts. The circle, the square, and the triangle together. Now what we have done over here is we have taken a circle with a radius 1 just as a unit. We have taken a square which has one side as 2, that is the diameter of this circle. Now if you see carefully, the circle is touching the square at all the 4 points. That is, the diameter of the circle is equal to side of the square. We have taken the same square and the circle and expanded as a 3D object. The 3D object is the sphere and the cube, because we need to study the 3D objects also. So this is the sphere and the cube. Here, the sides of the sphere, 1, 2, 3, 4, here over here 5, and on the back side 6. All the 6 sides of the sphere touch the cube. That is, the radius of the sphere is, that is, the diameter of this sphere is equal to the side of this cube. Now, if we only try to find out the area of the circle and area of the square, it is much more interesting in terms of formula. The area of the square is side into side, that is side square, and area of the circle is pi r square. We'll try to find more about this when we want to find the relation between the square and the circle. Again, we are finding more about the platonic solids. The cube or the hexahedron is one of the platonic solids, and that's why we need to study more about this platonic solids, which give a lot of knowledge about the sacred geometry. This is the cube fitted inside a sphere, which is taken from the W.D. Gann's book, Master Commodity course. This is something in real life that we can see as a 3D cube and a sphere. Now to find out the relation between the circle and the square, what we have done is we have taken a circle which has a radius r and the diameter is 2r. The side of the square is equal to 2r, or the diameter of the circle. So we have area of a square which is r into r, that is r square, and area of a circle is pi r square. So this is as per formula, and we know that the value of pi is 3.14. But how did this formula come into existence? How did we find out the value of pi, which is coming to 3.14? We need to understand about this part also, because when you are actually trying to find out the area of a circle, which probably was quite difficult, so they started with something as a square, and from this square we were able to find out the area of the circle. So assuming that this is a small square which has an area which is r into r, that is r square. Now let's assume we have a square which side is r. So the area of this square is going to be r into r, that is r square. We have this bigger square which has one side as d and its area is d square. Now we have this circle which is marked in red and we have its area as pi r square and the value of pi is 3.14. Now to have a relation between this square and the area of circle, the area of the square is r square, and probably if we try to substitute it from the first equation into the second equation, that is r square, we have area of circle is equal to pi, that is 3.14 into area of the smaller square. To get the area of the circle, we can understand that we can fit in 1, 2, 3. 3 squares, that is 3.14 into area of square, and this 0.14 can be the area which is there from this fourth square. Now this is probably how we were able to have an interpretation for the area of the entire circle from the squares that we have, and this is how we will be able to probably get the value of pi also. Now the value of pi is 3.14159265. The most interesting thing about pi is also been encoded as a value and has been given into various systems. Now there is a system in India which is been called as the Katapayadi system. Now in this system, the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0 are been given values as per K, T, P, Ya. So K is 1, T is 1, P is 1, Ya is 1, and accordingly K, K, D are been given values over here. So if we equate this value is one of the shlokas from Bhagavad Gita, we get the value of pi, which is 3.14159265358979, and we can get the entire value of pi over here. You can also see a YouTube video. In the same way, if we follow the system of Katapayadi system or the Katapayadi Sankhya, this shloka of Bhagavad Gita can be encoded as into the value of pi. So it is not only in Pythagoras system, but also in Indian system, especially the Katapayadi Sankhya, that we are able to know the value of pi. So in the ancient ways, probably this is how they were able to encrypt the value of 3.14, that is pi. And this is how they were able to get the value of the circle. That's how the square and the circle are related to each other. And that is how we will be able to learn more about the sphere and the cube together. Thank you so much. We'll meet again in one more interesting video similarly.